I'm going to make sure I get scientific notation in the book because that's the last thing that I test you on. I did go over percentages, but I didn't get to because I was asking simple questions and nobody was answering them. So I just had the proverbial meltdown. All right, so here is my whiteboard. And I'm going to start with scientific notation. And the biggest thing about scientific notation is that you have to make sure you know the definition. Now, I'm going to go ahead and tell you that some people think they know scientific notation, and they do, as to a certain point, but they don't when it comes to multiplying, dividing, adding, and subtracting scientific notation. That's where things kind of fall apart. So the Hubertism definition of scientific notation is writing very large / small numbers in a standard form where the decimal is to the right of the first number greater than 0. Now that is a Hubertism definition, but that is the definition that I will use. And if you learn this definition, especially the part right here, if you remember that part right there, that will help you out tremendously when you're doing scientific notation. Writing very small or large numbers in a standard form, where the decimal is placed to the right of the first number greater than 0. Now, most students can do the following 2 problems, or the following 4 problems. This is where you don't have a problem. 0.00313. And that's in decimal notation. It's got a decimal right there. And the test or the instructor asks you to write this in scientific notation. Well, take my pink highlighter or pink pen. The decimal goes right here because we know our definition. So that's going to be 3.13 times 10 to the blank. Let's count how many places. 1, 2, 3. To the third. And which way do I move this decimal to get it back in my head, to get it back the way it was? To the left. So your answer is 3.13 times 10 to the -3rd power. Now I asked that one little question right there because most people will get the 3 correct. But what will you screw up? You'll screw up the sign. So I always ask myself, right here, I always ask myself, put a note right here. Which way do I mentally move the decimal to get original form? There's my decimal right there. Which way do I mentally, what does mentally mean?
In your head.
Which way do which way do I move this decimal in my head to get it back to the way it was? Well, that's right here, right now. To get it right here in my head to the left, and left means negative. Now, there are people that say, well, my teacher told me it was always a small number and put a negative, and it was always a big number, put a positive. Well, that's not going to do you any good when you get to adding, subtracting, multiplying, and dividing. And then you're going to say, well, I don't understand why I got it wrong. And I'm going to tell you because you didn't follow that rule. Okay? So that sign right there, I always go back to here and I say, which way do I move this decimal in my head to get it back to look like this, to the left? And left is associated with negative. And then the teacher gave you one like this one, 3,200,000. And they said, well, decimal's going to go, take my pink highlighter, decimal's going to go right there. On a whole number, the decimal is right there. So I'm going to move the decimal 1, 2, 3, 4, 5, 6. So I'm going to rewrite as 3.2 times 10 to the blank 6. And now I'm going to ask myself, which way do I move this decimal to get back to the way it was? To the right. So that's going to be a positive. And again, most students don't have a problem with these. Then you got one like this. Write this as a decimal notation. 3.16 times 10 to the 4th. And that'll be on the test, and you'll go, okay, I got to move that decimal to the right because that's a positive, because there's nothing there. So I got to move that decimal 3, 1, 6, 1, 2, 3, 4. So the answer is 31,600. And again, most of you won't get that wrong. Most of you get that right. And then they got this one, 3.17 times 10 to the negative 3rd. And you'll go, okay, that's negative, so that means I got to move it to the left, so that'd be 2 zeros. And like I said, those 4 right there is not what students miss. And that's the ones they put on the test because students don't miss them. So hopefully y'all are one of those that don't have a problem with any of these. And if you do, send them to me in the homework and I'll do them with you. But that's not the one I'm expecting to see on the homework questions. Word problems, yes, because that's what I will put on the test. I'll put word problems on the test. But here's the ones that some of y'all have never seen before, such as adding and subtracting scientific notation. Now, when you add or subtract scientific notation, it's just like terms. If you don't have like terms, you're going to have to add them the old-fashioned way. But if you have like terms, you can add them how you want to. For example, I didn't turn my video on. I'm sorry. I don't want to be hypocritical. I turned my video on so that way students won't say, oh, you didn't turn the video on. Okay. So anyway, 2.0 times 10 to the 5th plus 3.0 times 10 to the 5th. Now, if you notice, these two guys are the same. If these are the same, that's a good thing, because that means they're like terms. And like terms, you just carry them down. What's 2 cans of soup plus 4 cans of soup? 6 what? Cans of soup. So the label doesn't change. So when you're adding and subtracting, this just comes down. And then you just add those two guys. 2 plus 3 is 5. Now, I always put scientific notation in terms of a decimal. And I do that because, and that point is not supposed to be there. I always do that because that way, if you need to move the decimal, you know where it is. Okay, so this is how you add or subtract. So if I have 6.0 times 10 to the negative third minus 2.0 times 10 to the negative third, again, I have like terms. Like terms means you just bring them down. And 6 minus 2 is, and I guarantee you there's somebody out there that's never seen where you add or subtract scientific notation. Now, what if they're not alike? Well, if they're not alike, then you have to go back to the old way of doing things. So let's say you have 2.0 times 10 to the fifth minus 1.0 times 10 to the third. Well, in this case, they do not equal. So we'll take a red or pink highlighter and highlight that these are not equal. So therefore, you've got to turn both of them into decimal notation. So 2, 1, 2, 3, 4, 5. 200,000 minus, well, that's going to be 2 zeros, so that's going to be 1,000. And the zeros cancel to 0. And 200 minus 1 is 199. So if you add or subtract and you don't have like terms, then you have to turn it into the decimal terms. Or you could do it on your calculator, and I'll show you how to do that also. Well, I'll show you right now. To type in an exponent, I thought I had my calculator pulled up. Really? Well, I thought I had it pulled up. As soon as it comes up, I'll do it. Well, it takes the SmartView calculator a couple of days to pull up. I'm sorry. Well, thank you. Finally. So the exponent key, basically, I don't see it. There's an EE key somewhere on your calculator. I don't use it. But all you do is hit 2.0 times 10, shift up, or to the fifth, minus 1.0 times 10, shift up to the third, and hit enter. And there it is. Now, I think there's a way you can turn that into scientific notation, but I really don't know how to do that. I think it may be under math. No, let's see a number. No, I don't see it. I thought it would be under number. Let me go down and see if they have. No, I didn't see it. Let me go down here and see if they. Nope. So anyway, clear, escape, second quit. That's your answer. Now that would be 1.99 times 10 to the 5th power. Now another rule you could use, usually the answer usually comes out to be to the 5th power. Okay, the highest power usually holds, usually. But there are some instances where it doesn't, so the best thing to do is just go and use the old-timey decimal notation or the calculator. Now sometimes your calculator will put that out like 0.2 divided by 0.8 or 5 or 8. Okay, well, let's go with 0.2 divided by 600. There is your scientific notation there. When the calculator gives you an answer, 3.33 times 10 to the -4th power. So some of you may need to write that down, because some of you, when you get your, answer in the calculator, you see that and you go, you start slobbering all over yourself because you don't know what it means. That means 3.3, repeating, put a line over it, times 10 to the -4th. So now there is a way here, I think you can approximate it. And there used to be an equal sign above this answer down here, but I don't have it anymore. Let's see if I can hit second and solve, or second enter. There used to be a key you could hit to get the approximate, but I don't know where it is anymore. There's the EE key right there. I just saw the EE key. It's above the comma. I don't think I'll have to get APX is what you're looking for, but I don't see it. I'll have to look that up. Okay, so again, that's probably things that you've never seen or probably have forgotten. When you're adding or subtracting, likes, they just come down. Unlike, you either do it on the calculator or you go back and use decimal notation, which is regular notation. Any questions on those 3 problems? Now let's get into what I'll test you on. Now I'm talking maybe 1 or 2 questions on this. But where I test you on is multiplication and division, because that's where everybody screws it up. Multiplication and division. Hold on just a second. I'm sorry, my mother called. Hold on. Oh, my Lord. Her cat got in a fight. Sorry about that. I guess that was an emergency in her eyes. Usually when my mother calls, she knows I've got class, so I thought it was something bad. Evidently, he got tore up pretty bad. All right, so multiplication and division. Multiplication and division, just do it, okay? But you've got to remember scientific notation. The directions will say, make sure your answer is in scientific notation. And that's where you have to remember the definition of scientific notation. This is where students get the problem wrong. They'll do 90% of the problem correct, but they'll screw up the answer. I'd say if I gave you 10 scientific notation problems and I gave you 2 of these, 90% of the class would miss these 2, because that's that y'all forget this last part right here. So here's an example. 15.0 times 10 to the 4th multiplied by 3 times 10 to the 3rd. Now, a lot of students would tell me, they'd say, well, it don't start with scientific notation. Well, it doesn't have to start with scientific notation. Your answer has to end in scientific notation. That's the catch. So everybody knows that 15 times 3 is 45. And what do you do if you have the same base with exponents? What's the rule? Somebody tell me the rule. If you have the same base and you have exponents and you're multiplying, what do you do to the exponents?
Do you add them together?
You add them. So that would be times 10 to the 4 plus 3. 45 times 10 to the 7th power. Students will write this down as the answer, and it's not the answer, because what do you have to write your answer in? You have to write your answer in scientific notation. That's not in scientific notation because the decimal is right there. And that's why students get these problems wrong. Now, if they do remember to move the decimal, what happens? Well, they get the sign wrong. So this is the way I tell students to do it. Move the decimal. I didn't say a direction, I just said move it. Move it to where you got to have the definition of scientific notation satisfied. 4.5 times 10 to the 7 blank 1. Now, which way do we mentally move this in our head to get back the way it was? To the right. And that is your final answer. 4.5 times 10 to the 8th power. Where do students get it wrong? Well, they get it wrong from here to here. And students will get to the 6th power. I don't know how they get it. I don't know why they get it. They just do.
So you have to add one.
I'm sorry, say again?
One place over.
Say it one more time, Mr.
So you have
Lewis.
to
What?
add 1 to. So you have to add 1 to the
Exponent.
7 because you're moving the decimal place over 1.
Yep, you have to move it to the right. Now,
Okay.
let's go to the handy dandy calculator and see if I'm right. Because I have had students say, that ain't right, that ain't right. Let's do it. 15 times 10 to the 4th. 15 times 10 to the 4th. Multiplied by 3 times 10 to the third. And enter. 45,000. There is a way to put that in scientific notation. I can't remember how to do that. And second, I'm going to figure it out right quick. Hold on. I know I don't have much time, but I'm going to figure it out. On the TI-83, it used to do it with approximate. But I don't know how to do it on these newer calculators. Anybody know? You could communicate it if you knew. TI-84 plus from decimal to scientific.
Don't you click mode and then switch it from, it'll be like the normal section and it says sci. I think that's what you
Is
click.
that what it is? Okay, let me go back. But I was thinking that's on a umbrella basis. I was thinking of of just by problem.
Oh, gotcha. That's right.
Mode. Yeah, you could change it to that. But then what happens when you need decimal? You have to switch back and forth? I mean, we could do that. Second, quit, enter. 4.5 times 10 to the 8th power. Oh my gosh, that's what I got. So evidently, Hubert's right and the calculator's right, or you're wrong, if you question it. I'm not saying you did, Ms. Ballou. I'm just saying that, some people, this is where you don't get the questions right. And you always ask yourself that one question. That's why it's pink right here. Which way do I move this decimal in my head to get it back to the way it was? In my head, to the right. Right corresponds with plus. So that's why I get to the 8th power, just like the calculator got. Let's do nerd. I usually do 2 of each because this is where students really screw up scientific notation. So let's do 7.0 times 10 to the negative third times 3.0 times 10 to the negative sixth. All right, I'm going to let y'all do that one right quick. I'm going to type it in a calculator. Well, since I know where my E is now, I'm going to show you how to do that. 7 second, comma, negative third times 3 second, comma, negative sixth. So 7 times 3, 21, times 10 to the negative 3 plus a negative 6. Oh, this got negatives in it, so I know y'all screw this one up because y'all can't do negatives or fractions. So that'd be 21 times 10 to the negative 9th. I got to move this decimal one place, so that's 2.1 times 10 to the negative 9 blank 1. Which way did I move this decimal in my head to get it back the way it was? To the right. So 2.1 times 10 to the negative 8th power. And I guess me and the calculator are in cahoots. Because I guarantee you somebody got negative 10. Move that up a little bit so I can get the calculator on there. Not that anybody's going to watch this video, but it'll be on there. Leave that on there for a few seconds. And let's do a division problem. Uh, 50 times 10 to the negative fourth divided by 2 times 10 to the negative sixth. All right, I'm going to give y'all a second to do that by hand, you know, with what we've been doing like this. And then I want you to do it on a calculator and see if you get the same answer. So 50 divided by 2 is 25, and 10 be a negative fourth minus a negative 6 will be 25 times 10 to the negative 4 plus 6 is positive 2. Move it one place. Which way do we move this decimal in our head to get it the same, get it where we were? To the right. 2.5 times 10 to the third power, which in real is 1, 2, 3, 2,500. So let's see what you actually did. You actually took, that's 3 zeros, 0.0005 and divided by, that's 5 zeros, 0.000002. That's what you actually did, 2,500. That's why scientific notation was developed. Scientific notation was developed so you didn't have to do this by hand before calculators came around. So you got to think to yourself, it took a real genius to figure this stuff out. So you wouldn't have to do this in your head, I mean, by hand. Let's check with the calculator though, because people still don't believe that I'm getting the right answers because I'm doing exactly what their kindergarten or K through 12 teachers told them not to do. So let's go ahead and try it. 50 e to the negative fourth divided by 2 e negative 6. 2.5 times 10 to the negative to the positive third. Oh my gosh, that's what we got. So those of you that got 10 to the first power, your way is not correct. Comprende? All right, let's try another. $25. No, let's don't do 25. Let's do, we did 50 that time. Let's do 60 times 10 to the 7th divided by 3 times 10 to the 5th. So for those of you that don't know what we're doing, that's like 60 million or 6 million, 60 million. 1, 2, 3, 4, that means 6 zeros. Yeah, 60 million. Divided by 5 zeros would be 300,000. That's what you're doing. And you're doing it with scientific notation, so you don't have to rely on a calculator. So 60 divided by 3 is 20. 7 minus 2, sorry, 7 minus 5 is 2. So that's 20 times 10 to the second. Move the decimal one place, 2.0 times 10 to the 2 blank 1. Got to move it to the right. So that's going to be 2.0 times 10 to the third power. So if you did want to change that to regular notation, 2, 0, 1, 2, 3. So your answer is 2,000 or that number. So 60 million divided by 330,000 is 600 divided by 3. Well, that's not right. I think I got a 0 off. Wait a minute. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. I got something off. It's supposed to be 6,000 divided by 3.
You missed a 0. You went across.
Did I?
Yeah. Like your last line when not straight
Okay.
down.
Okay. Okay. Well, let's check just to make sure. So 60 EE 7th divided by 3 second EE 5. 2 times 10 to the third power. Which is 2,000. Now, these two things right here, multiplication, those two right there, and these two right here, which is division, well, not that one, division. Where's my division? Oh, division and multiplication. Those are the 4 problems that'll give you, you know, a little bit of trouble. And then if I throw word problems on top of that, then y'all's head will explode. I don't know if they give you any word problems in this homework. We can go back and look. Let's look and see. Oh, I hit the wrong one. I think this is 3B. Should be your last section of homework. 3B. Yep. And let's see if I can find one that I would put on the test. Trying to find one that they're asking you to actually multiply. That could be 1. Find the scale ratio for the map and describe 1 millimeter of the map represents 1,000 kilometers on the ground. Thirty-two thousand 100 citizens of a country died in automobile accidents in 2000. Why didn't they say death of cars like they did with the guns? Should do the same thing. Approximately 32,100 citizens were killed by cars in 2015. Express this toll in deaths per day. Well, you could do that, but I don't know if this is going to be scientific notation, but we can try it. So let's go with $32,100 citizens died by car. I think it's only fair that since they say by guns, I think it's only fair by car. The car just cranked itself up and ran over somebody. Over 1. Okay, since they didn't give us per. And they said, that says per, is that 1 year? See, now this is where they get vague. In 2015, so that'd be 1 year. They're a little bit vague about that. They should say, instead of 2015, they should say in 1 year. But anyway, express this toll in deaths per day. Well, how many year has to go up top? So how many days are in a year? 365. And the years cancel. So it'd be 3.21 times 10 to the 4th. 1, 2, 3, 4. Divided by 3.65 times 10 to the 2nd. 1, 2. So this is an example of what I was talking about with division by scientific notation. So this you would do in the calculator, and this you would do, that'd be 10 to the 2nd. Take your handy dandy calculator and do 3.21 divided by 3.65. And that'd be 10, well, actually be this 8.79 really, but they want you to move it 0.879, 0.879, blah, 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 and put dots right there. But that's not the scientific notation, is it? Nope. So you got to move it one place. So that's going to be 8.79 ... times 10 to the 2 blank 1. Which way do you move this decimal to get it back the way it was? To the left. So your final answer is 8.79 ... times 10 to the 1st power. So that means 87.9, which means 88 people per day die by car. Not by the person driving the car, but by the car. What's good for the goose is good for the gander. Y'all ever see that question? I don't know if y'all saw it or not, but it might be in the 120 class. Yeah, it is. It's in the 120 class. The question says, if 75.6 people die by firearms in a year, then how many people died by firearms in with 300 people being murdered, you know, and then you got to multiply the 300. So I just interject a little piece there. I put how many people died by people using firearms. There's a distinction between people using firearms and firearms. Firearms don't just get up, walk off the table, walk out the gun case, and shoot somebody. Neither do cars. So 88 should be your answer. So let's go look. 88 deaths per day. And you feel good about yourself. Now that right there is a test question. That's the type of question I would give you with multiplying or dividing scientific notation. At the end of the year, the gross debt of a country stood at about 15 trillion. Express this amount in dollars per person. Assume that the population of the country is about 295 million. So you're going to take the debt and divide it by the population. So go ahead and do that. I'm going to let y'all do this one. I'm going to write it out so you can see what it looks like. 15 trillion. Well, this is 1,000. And this is 1,000,000. This is 1,000,000,000. And 9 or 15 trillion would be 3 more. So 15 with 12 zeros. Divided by, what did it say? 295 million. So that'd be 295 with 6 zeros. So this is what we're doing. If I can get my mouse to work. That's what you're doing right there. So that's 12 zeros, 13. So that's going to be 1.5 times 10 to the 13th power over 2.95 times 10 to the 8th power. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8. And the decimal on the whole number is always right here. I moved it. First number greater than 0 is 2. First number greater than 0 is 1. And 13 minus 8, I have no earthly idea because I can't stand to subtract 8s. What is it? I have no idea. 13 minus 8 is what? 5? Somebody help me out. I hate subtracting
Yes.
8s. Thank you.
Yes, it is.
Y'all ever have a number that you can't stand to subtract? 8 is my number. I can't stand to add or subtract 8s. None of y'all have a number that you hate?
Why?
What?
Why do you hate 8s?
Because I don't know them. I always get confused. There you go. And let's take our handy dandy calculator. 1.5 divided by 2.95. So that's going to be that's going to be let's see, it's going to be one place to the left, so that's going to be point. Well, that's in scientific. No, it's not. Yeah, it is. That's scientific notation. Well, I'm going to rewrite it. So that's going to be 0.50847 times 10 to the 5th. And now I can do it right here, move it one place, and that's going to be 5.0847 times 10 to the 5 blank 1. And which way do I move this decimal in my head to get it back the way it was, to the left? And that's going to be 5.0847 times 10 to the 4th, which would be 1, 2, 3, 4, which would be 50,847. 50,847. Let me look at the calculator to make sure that that 7 is a 7. Yeah, because that 4 does not bump it up to an 8. So 5,000 or 50,847. So 50,847. If each person would give up their paycheck, including the rich, the poor, and the middle class, it'd average out to be about 50, because the national income right now, the average is around 50 to 55,000. So if everybody was to give up their paycheck for 1 year, the national debt could be taken care of. Yeah, and we're way past 15 trillion. If you don't know, most people don't know coming out of high school, because that's something they want to what? Keep from you. So check. Whoop. They wanted in scientific notation. Oh, round to the nearest hundredth. 100. So that would be, I don't know, you could say 50,900 or 50,800, since that 4. There we go. And that's the last one. So those last 2 questions of your homework are pretty good. I'd say probably the last 4 questions probably are good, because I know that's multiplication. That's multiplication. Yeah. Probably those last 3 or 4 questions. So who's got questions about scientific notation? I guarantee you some of y'all thought you knew it.
I've never done that before, but can we have the easy ones for the test?
Yeah, sure. I'll give you the easy ones. Yeah.
You're great.
Make sure you can multiply and divide, okay? But especially with you, Miss Gildner, Miss Glendemer, Miss Gill, you're in the health field. You need to know how to switch to scientific notation quickly.
I know.
That's all right. You can just let somebody die.
I suck at word problems.
What?
I suck at word problems, so it always makes it more difficult for me.
Well, you got to overcome that, especially before I come to the hospital and you're my nurse. I want to make sure you know how to do scientific notation. I don't want to die of, being overdosed.
Okay, I won't do that.
Any other questions? All right, now I'm going to leave Wednesday and Friday for homework on anything, because technically I'm done. So I'm going to leave questions for y'all Wednesday and Friday for homework on any sections. Oh my gosh, you can go back and do any homework? Any questions you got, send them to me Wednesday and Friday. Y'all have a good day.
You too, thank you.
Thank you.
All right, bye-bye.
Thank you.
Thank you.
Bye-bye. Thank y'all for interacting with me. Thank you very much. Bye-bye. And I'll wait for the people that left their computers, wait for them to see if they're going to leave.